So for this lesson, we're going to continue our review of grade 10 material, and we are focusing still on the idea of quadratic relations. Rather than looking at the algebra in this lesson, of course algebra will come up, but here we're going to be looking at some of the more conceptual items that you should have learned in your grade 10 course. So let's start off with a recap of the different forms of a quadratic relation and the information that you get from those forms, because each of those forms gives you a different piece of useful information. For example, in standard form, which is the first one I've got here, so in standard form, the most useful piece of information from standard form is going to be from this C parameter, and that's going to give you the y-intercept. In factored form, you get two pieces of information. Those are the values of the zeros. So depending on what these numbers are, those tell you the zeros. Now this is in the case of something that has an integer set of zeros. You could also have something that has fractions or decimal zeros. It's going to look a little bit different, but it can be represented this way as well. So you can always put it into this form. And then finally, we have vertex form. Vertex form, two pieces of information that you really want to focus on, h and k. The h tells you the x-coordinate of the vertex, and the k tells you the y-coordinate of the vertex. And of course, across all three of these, I have not yet mentioned the a value, and as you can see, it's certainly possible to set up any of these three equations so that the a value is the same. With standard and vertex form, the a values are always going to be the same. And the only reason why I'm qualifying this, you might think, well, shouldn't the a be the same no matter what? In general, the a value for factored form will be the same, but there are a couple of subtle different ways that you can write factored form. And so you just have to be very careful to make sure that if you want to compare a values between, you have to make sure that your factored form is set up exactly this way, okay? And what does the a value tell us? So the a value is going to tell us things about direction of opening. So does it open up or does it open down? And if you are comfortable with, or if you've learned about it, you can use the a value to generate what's known as the step pattern, which can help you quickly and easily come up with a sketch. Another piece of information that we get, technically we get this from vertex form directly, which is that the h value, so if you know the h value from vertex form, that allows you to know what the axis of symmetry is. And that can also be very useful. So here we have a request to sketch the parabola. And the way we're going to sketch that parabola is because we have access to all of these different pieces of information, we should actually be able to come up with a fairly accurate sketch. Notice I'm not worrying about my scale, and I don't have a grid, even though I'm using technology, so I could easily put that in. I'm just going to do a sketch, and in the grade 11 course and going on to the grade 12 course and more advanced math, that happens more often than not. Yes, you will still be asked to do precise graphs with a grid, but more commonly you're going to be asked to do sketches because the graph itself might not be the end goal. You want to just get an idea from the graph and maybe use that to go on to more sophisticated concepts or conclusions. So let's take a look at what we've got here. I'll label these equations 1, 2, and 3 just in the order that they appear, so I can refer to them. So what does equation 1 tell us? Well, equation 1 is in standard form, and as I pointed out in the previous slide, standard form is going to tell us about the y-intercept. So the y-intercept, which we get from standard form, is equal to 9, or you can refer to that as a point which has an x-coordinate of 0 and a y-coordinate of 9. That's what a y-intercept is. The x-coordinate is 0, the y-coordinate is 9. So I'm just going to eyeball this. I'm going to put a 9, let's say, around there. So there's the point 0, 9. Okay, let's take a look at equation 2. Equation 2 primarily tells us that what the zeros are. Now again, you can see in this case, all of the a values are actually -3. So this factored form equation is set up using the kind of default configuration for factored form. So that a value is the same a value across them. I'm not going to try to come up with a counterexample for you here. That's the kind of thing that is better to have as a classroom discussion. So this is going to allow us to find the zeros. Now, if you're comfortable with this, you can probably just go ahead and read the zeros right off of here. But what does it mean to be a zero? A zero occurs when the y-coordinate is equal to 0. It means it's on the x-axis. So again, this is a review, and I don't want to leave out things that might have slipped out of your mind since you last looked at this. So if we look at this equation and we set y equal to 0, we end up with 0 equals -3 multiplied by x plus 1 multiplied by x minus 3. And strictly speaking, that's how you find the zeros. So what I have here is a product. I've got -3, which is a number, multiplied by this other factor, which is x plus 1 in the brackets, multiplied by this third factor, x plus 3, or sorry, x minus 3. Now, the only way that you can take things and multiply them together and end up with a 0 is if one of those things is equal to 0. So first of all, the -3, well, the number -3 is never 0, okay? It's not possible for the -3 to be driving this to be a 0, because when you multiply something by -3, you don't produce a 0. X plus 1, well, depending on the value of x, maybe x plus 1 could be 0, and so that's what we consider here. We say, okay, what would it take for x plus 1 to be equal to 0? That's essentially the question we ask ourselves. And of course, the very obvious answer to that is that when x is equal to -1, that's going to make this middle factor a 0, which is going to drive this whole equation to 0. So one of your zeros occurs at x equals -1, and another 0 could occur if x minus 3 is equal to 0, which occurs at x equals 3. You could represent these as points. So this one is actually the same as the point -1, 0. And the second one is the same as the point 3, 0. -1, 0, going back to our sketch. Based on the scale I've chosen here, -1, 0 looks about there. -1, 0. And 3, 0 looks about there. Again, I'm just trying to be in the right ballpark. I want my sketch to resemble reality, but I'm not going to be too strict about it. And then finally, the last thing we take a look at is vertex form. So we want to know, where is the vertex on this? And finally, where's the vertex? Well, you can see from here, the vertex is going to be at h, k. And that's simple enough for the k value. The k value is just whatever this number is outside, that's 12. But it is worth remembering that vertex form is y equals a bracket x minus h all squared plus k. So just a reminder that the part inside here has to be in the form x minus h. So this is x minus 1, which means the h value here is actually +1. And so our vertex has coordinates 1, 12, which puts it around there. And that's the highest point of this parabola. So now I actually, and of course, if you take a look at the a value, it's -3. For a sketch, we're not going to draw out a step pattern because we're not worrying about scale, but the negative tells us this parabola opens down, which is evident from the data points that we put together here. And I'll just try my best. I'm probably not going to do a very good job with this little tablet that I'm working on, but I'll just try my best to draw a smooth curve. You'll have to forgive. This is really coming down to my lack of dexterity or coordination with this, working with this tablet. Okay, so that's something that's at least passable here. And there is my sketch of my parabola, using information from all three forms of the equations. I could have made a graph using only one. I could have created a table of values. But it's just important to know that all three equations contain different important pieces of information about the parabola. As is often the case in math, it's quite common for us to look at things from the reversed perspective. Here I started with equations and asked about what the picture looks like. I could go the other way and I could say, well, here's a picture. Can you tell me what the graph is here? In this case, I have three obvious pieces of information. I have the y-intercept, which is equal to 10, and I have the zeros, which are at 2 and 10. Now notice how I wrote this, 2 comma 10, I'm listing two different numbers. I did not put brackets around this. If I put brackets around this, it would look like a point, x comma y. Instead, I'm talking about 2 comma 10. Another way I could write this would be as points. So I've got the y-intercept, which is at 0 comma 10. I have zeros, which are at 2 comma 0 and 10 comma 0. So notice the distinction in those two different ways of writing the same information. I have no information as yet about the vertex. I have some indirect information. Because I know the zeros, I could go to the axis of symmetry, which we can see pretty obviously is here at 6. But the information I'm being provided most directly is here, and I'm being given the most information about factored form because I've got the zeros. So the thing that makes the most sense here is to actually write this in a generic factored form, x minus s, x minus t. You could, because we already have that information, you could have gone straight to x minus 2 and x minus 10. So you didn't need to rewrite that first line. And now we don't know what this value of a is. So in order to resolve that, and I say that right here, in order to resolve that, we're going to sub a point to solve for a. And so that's what we're going to do now. And the point I'm going to sub is, I can't use a point that I've already used to fill in the equation. So I can't use either of these zeros because the zeros are all used up. And so I'm going to sub the other point that I know, which is the y-intercept, which is at 0 comma 10. The y coordinate is 10. So where I had a y before, I'm going to put 10. A times bracket x minus 2, which is going to become 0 minus 2 because the x coordinate is 0. And x minus 10 is going to become 0 minus 10. So I end up with 10 equals a, and this is just negative 2 times negative 10, which is equal to positive 20. Divide both sides by 20, and I end up with a equals 10 over 20, or a equals 1/2. So now I have my completed equation. Y is equal to 1/2 x minus 2, x minus 10. And I could convert this equation. If I was asked to come up with this equation in one of the other forms, standard form, I would just expand and simplify. Vertex form, there'd be a little bit more work to do. I would then make use of the fact that the axis of symmetry is here along 6, and then I would use that to find out the y coordinate of the vertex. But I would only do that if the question specifically asked me to do that. In this case, it just says to determine an equation, doesn't specify the form for the equation. And so we are fulfilling the obligation of this question by providing a factored form equation. Expanding and simplifying. So now we're back to an algebraic technique. Expanding and simplifying is using what's known as the distributive property, which means everything in the first binomial bracket gets multiplied by everything in the second. And in this case, we actually have this constant 2. I do recommend you take care of the more difficult part first, So in that case, that would be multiplying out the binomial. So every part here has to be multiplied by every part in the other bracket. So the first bracket, every part gets multiplied by every part of the second bracket. And the way that we remember this is an acronym called FOIL. So you don't need to use the acronym. You're just using the distributive property. But FOIL helps us remember this: first, outer, inner, and last. So notice the first things that multiply together. So let me go ahead and start to work this out. I'm going to leave the 2 there for now. X times x, those are the first ones. That's x squared. X times positive 4, that's plus 4x. That's the outer. Negative 3 times x, that's the inner. That gives me negative 3x. And negative 3 times positive 4 gives me negative 12. And now all I need to do is simplify. Actually, I have 2 more things to do, because once I simplify the bracket, I have to multiply by this 2. So I end up with x squared. There's nothing to simplify with that. 4x minus 3x just leaves me a single x minus 12. And now I multiply that out. I end up with 2x squared plus 2x minus 24. Because this 2 has to be, it's the distributive property again, has to be distributed into every term in our bracket, in that factor. Part B, same idea. It's just looks a little different. It's got a fraction in it, which sometimes people aren't always comfortable with. So expanding and simplifying, I'm going to focus on this perfect square portion first. Negative 2/3. And just a reminder, you can go straight to your expansion here, but just to remind you, if you're not sure, remember a perfect square like that is just x plus 5 times x plus 5. And that means you have to use FOIL. The most common novice mistake that people make here is they think they only multiply the x's together and they only multiply the 5's together, and they forget about the middle term. Because there is, in fact, a middle term here, so negative 2/3. And when I'm going to do this in one step, which is you end up with x squared. The middle term ends up being x times 5, which is 5x, plus another 5x, so that gives us plus 10x. And then the last is 5 times 5, the constant value, that's plus 25 minus 8. Now I distribute that fraction into the bracket, so I end up with negative 2/3 x squared. I've got negative 2/3 multiplied into that 10. Remember that that 10 is like 10 over 1, and that 25 is like 25 over 1. So this actually becomes minus negative 2 times 10, so that becomes minus 20 over 3, because 3 times 1. Numerator times numerator, denominator times denominator, and then times x. You could put this x up here in the numerator as well if you wanted to. That would be perfectly fine, and sometimes it's more convenient for us to write it that way. Negative 2 times the 25 gives us a negative 50 over 3. And I could write minus 8 here, but with a little bit of foresight, you might realize, well, hold on, this term is a constant term, so I'm going to have to combine those. So why don't I just go ahead right now and put this one over 3 instead? So instead of writing this as minus 8, or essentially 8 over 1, let's multiply top and bottom by 3, giving the denominator a 3, and the top ends up becoming 24. So we have minus 24 over 3. And that allows us to finish this off, because now we have to do the simplifying part, because those two terms can be simplified into one term. We end up with negative 2/3 x squared minus 20 over 3x minus, and this one's going to be minus 74 over 3. And one other thing I'm going to point out there is that it is always your responsibility, it is always the expectation that you are reducing your fractions. Now, in this case, none of these fractions can reduce any further, but you have to make that mental step. You have to check that yourself to make sure that you have reduced them fully. And our final example in this review lesson, use symmetry of the vertex from factored form. Okay, so we're not using symmetry of the vertex. We're using symmetry to find the vertex. That's something I referred to on a couple of slides ago from factored form. So the first thing we need to do is achieve factored form. And then I've got a couple of hints here. If we have factored form, the axis of symmetry is the midpoint of the zeros. And once I know the axis of symmetry, that's essentially telling me what the x-coordinate is of the vertex. That's what this part is. H and K, when we talk about vertex form, we write the vertex is at HK. If you know the axis of symmetry, you already know the H value. And if you sub that axis of symmetry into your equation, you will find the Y value. So what's actually happening here is this is the X coordinate of the vertex, and we can use that to find the Y coordinate of the vertex. So step one is going to be factored form and using that to find the axis of symmetry. So I'm just going to rewrite this, 2x squared plus 4x minus 30. Hopefully the first thing you notice here is there's actually a common factor. So I'm going to start with that by factoring out the 2. And I end up with x squared plus 2x minus 15. This is a simple trinomial in the bracket, but I'm going to go ahead and write it out anyway. If you're able to do this off the top of your head, that's great. 1 in front of the simple trinomial, really that means it's 1 times negative 15. So I'm looking for a multiplication into negative 15, an addition into positive 2, and my numbers end up being 5 and negative 3. So this is equal to x plus 5 multiplied by x minus 3. Once you know those numbers and it's a simple trinomial, you can go straight to your answer there. Now, finding the zeros. So to find the zeros, we want to set y equal to 0. Again, if you can see this, you can just go ahead and do this in your head. I just want to reinforce that concept that we're reviewing here, that this is the source of the zeros. You end up with an equation that looks like this. Multiplying by 2 doesn't turn anything into a 0. That means multiplying by x plus 5 could turn it into a 0. Well, that will occur when x plus 5 itself equals 0 or x equals negative 5. Or it could occur when x minus 3 equals 0, which is when x equals 3. And if you are proficient in this, you can recognize that from here, you can go straight to a conclusion that x equals negative 5 is one of the zeros. And from here, just looking at it, you can go to the conclusion that x equals 3 is one of the zeros. And that's perfectly fine. The only time where you would be required to show something like this might be if I asked you to show all of your work. I'm not inclined to do that in grade 11. That's very much more of a grade 10 requirement to make sure people are understanding it. Now that I know where the zeros are, I can find what's known as the axis of symmetry, which is the midpoint of the zeros. So the x-coordinate of the vertex, that's the axis of symmetry. The x-coordinate of the axis of symmetry is the x-coordinate of the vertex. That's the center line of the parabola. And it's the midpoint of these two zeros. So I take those two zeros. One of them is negative 5. The other one is 3. That's a pretty awful line. One moment. Again, I'm going to blame my tablet for that. And divide that by 2 to find the midpoint. Negative 5 plus 3 is negative 2. Divided by 2 is that equal to negative 1. So the x-coordinate of the vertex is negative 1. And now I sub the x-coordinate of the vertex, which is equal to negative 1. And I'm going to use that to find the y-coordinate of the vertex after I make that substitution. Now you can substitute it into your factored form equation, or you can sub into the original equation. Usually it's a good idea to sub into an original equation because that equation, there's no chance that you've got that wrong. In this case, because we then used our factored form equation to find our zeros, and we used our zeros to find our x-coordinate of the vertex, If we've made a mistake, that mistake is propagated throughout our entire solution. So in this case, it doesn't actually matter. I'm just going to make a choice and substitute it into the original form. I actually think it's a little bit easier to do factored form, but let's go back to the original form. 2x squared plus 4x minus 30. So it's 2x squared plus 4x minus 30, but instead of x here, I've got a value of -1. So I'm actually going to substitute for x, I'm going to substitute that -1, and I end up with the y value of the vertex. Well, -1 all squared is +1, so 2 times that is just 2. -4 minus 30, so the y coordinate of the vertex ends up being 2 minus 4 is -2 minus 30 is -32. Therefore, now what did it want? Vertex form, or did it want the location of the vertex? Find the vertex, it says. Therefore, my vertex has an x coordinate of -1 and a y coordinate of -32. And I believe that is it for this particular review lesson. I've got some suggestions for our current textbook that we're using. On my webpage, I have some additional a worksheet with some additional problems and even more supplementary problems. Supplementary just means optional. If you feel like you want or need the additional practice, then you can do those supplemental problems as well.